Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 2-3 and 4 of our series on coordinates, geometry, and lines. We're going to be looking at the distance and midpoint formulas in this presentation. Don't forget, there are 4 practice problems at the end for you to try out in order for you to demonstrate mastery of the contents of this tutorial. To gain access to our entire collection of math courses, arithmetic, algebra 1, 2, geometry, pre-calc, and calculus, take a look at the links in the description below. All right, for question number 1, what if we're given a graph of a line segment and we're to find the distance between it? All right, so number 1, consider the following question. What if you were to find the distance between 2 points on the graph? And then let's say that we have a coordinate system here, and then we have 2 points. The first point, let's say the point is right here, okay, and then we have another point. Let's say this is -2, 1, 2, 3, and this is 3, 1, 2, and this is 2 right here. Bam. Okay, so let's say we're to find the distance between these 2 points on the graph. So how do we go about it? So what we're going to do, let me give you a visual as to what we're trying to do here. We're trying to find the length of this segment from this point to this point right here. Okay, that's basically what the distance is. Okay, all right, so what we're going to do, let's label it. Let's say this is A, this point right here is point A, and this is point B. What we're looking for is AB. So we basically are trying to find AB. All right. Okay, let's do it. So what we're going to do, first of all, is we're going to write down the formula that will guide our problem solving process, which is the distance formula. Okay, so the distance formula is as follows. D, distance between 2 points, is the square root of the sum of the squares, the difference of the rise and the run. Okay, so you have, let's do the run first, x2 minus x1 square. All right, you might remember this from the rise of a run formula. This is your run along the x-axis, so you have that squared plus the square root of the rise, y2 minus y1 square. So that basically is your distance formula. It's basically the same thing as the Pythagorean theorem. All right, where you have a squared plus b squared equals c squared. When you get c isolated, this could be your a square and this is your b square, and then you have the square root of that. So that's basically what it is. So let's go ahead and apply that to this particular situation that we're dealing with right here. So we just need to determine what is x1, y1 and what is x2, y2. Okay, it doesn't really matter whichever one you call 1 or 2, but I'm just going to call the one to the left my 1's and then the one to the right my 2's. All right, so for point A, and then the coordinates of the second point B is 3, 2. So from the first point, we can figure out that this is x1, y1. This is x1, y1, the coordinates of the first point. And then this is x2, y2. Alrighty, let's write it out so it's clear exactly what we're doing. So from point A, we know that x1 is 0 and y1 is -2. And then from point B, we know that x2 is 3 and y2 is 2. All right, it's important to clearly identify what x1, y1, and x2, y2 are. Why? Well, it's because it helps you avoid making mistakes. We're going to go ahead and substitute these values into the distance formula, and then we'll be able to compute what the answer is. Okay, so let's go ahead and do it. So the distance in this case is basically AB, all right? So the distance D, which is the length of the line segment AB, is going to be the square root of um, the run square, x2 minus x1, so that's 3 minus 0 square, plus the right square. Y2 minus y1, 2 minus negative 2 square. And then we put the complete our radical bar. Okay, so don't forget, if you have any questions during the presentation, always feel free to place your questions in the comment section below if you need clarification about anything, and we'll be more than glad to clarify. All right. Okay, so let's keep on going. So we have the square root 3 minus 0 is 3. Remember, we're following the order of operations here to simplify this. So we have 3 squared plus minus times minus, slash and dash, it becomes a plus, so it becomes 2 plus 2. That becomes a 4. All right, so 2 plus 2, that's 4. Square that. We're still simplifying the radicand component. And then what is 3 squared? 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. All right, the square root of 25 is 5. So, ladies and gentlemen, AB is 5. So what does that mean in the context of this problem? The distance between the 2 points that were given, which were 0, negative 2, and 3, 2, is 5. There you have it. Okay, let's take a look at number 2. For question 2, what if the question is presented in a verbal format? Okay, you're asked to find AB when A is 3, 7 and B is 5, 3. So what on earth does it mean to find AB if you're given 2 points? Well, as we did in the previous example, if you're given 2 coordinates and you have to find AB or the length, AB, the letters for each of the coordinates right next to each other, like AB, that basically means you're to find the length between the length of the segment from one point to the other, or the distance between the 2 points. Okay. All right, so let's go ahead and work this out. Let's take a look at our distance formula again. Distance is the square root of your run square plus your rise square. Like that. Then let's put in our radical bar. Okay, so now we just need to figure out what is A and what is, x1, y1 and x2, y2. Plug it in and we're good to go. So for point A, we have 3, 7. And B, we have 5, 3. So let's just call A the 1s and B's the 2s. It doesn't really matter how you do it. You still get exactly the same answer, right? So keep that in mind. So for A, this is x1, y1. Just as we did before, and then for B, this is x2, y2. Now what we're gonna do is specify exactly what is what. Okay, so it's clear. X1 is 3, y1 is 7, and then for B, x2 is 5, and y2 is 3. So we're gonna input that into the distance formula. So AB is our distance, okay? That's what D is. And let's go ahead and input them. We have x2. X2 is 5. 5 minus x1, 3. square that, plus y2 minus y1. Y2 is 3 minus y1, which is 7. Square that. All right, we're going to work our way from the radicand component all the way out. Okay. Remember, order of operations, you would start with the parentheses and you work your way out from there. All right, so we have the subtraction operations in the parentheses, so we're going to take care of those first. So 5 minus 3 is 2, so we have 2 square, plus 3 minus 7 is negative 4 square. All right, so we're done with parentheses. Please excuse my dear Aunt Sally. Exponents are next. So let's simplify the exponents. We're going to go 2 square is 4 plus negative 4 times negative 4. Remember, minus times minus is positive, so that becomes positive 16. Okay? All right, so we combine those together, and that will give us the square root of 20. All right, so let's go ahead and simplify this. Square root of 20. Let's break it out into prime factors and see if there are any repetitions, any squares that are factors of this. So you can take out 2. 2 goes here, 10. Take out another 2. 5. These are all prime factors, okay? Oh, check this out. These 2 factors repeat. So 2 times 2, that's a perfect square. So this comes out as a 2. The square root of 2 times 2 is just 2. The 5 stays behind. So the square root of 20 is 2 rad 5. Okay? Okay, so if we simplify this, this is going to be equal to 2 root 5. So the square root, the distance between the 2 points, AB is equal to 2 root 5. Or you can also use your calculator if you want to do an approximation. Depends on what your teacher wants you to do. So if you do your calculator, it'll come out to approximately 4.47, rounding it to the hundredths place, to 2 decimal places. All right, so there you have it. All right, let's do one more example on distance formula. Then we're going to switch gears and take a look at midpoint formula examples. All right, so number 3, what if you're to find EF when point E is negative 1, 2, and F is 2, 1. Okay, if you already have the standard mastered, you can fast forward to the midpoint formula, but we're just going over this for more practice. All right, so let's do this. All right, so we're gonna go ahead and write down our distance formula. Hopefully you have it memorized. Is the square root of x2 minus x1, your run square, minus y2 minus y1, your rise square. Okay, so there goes your distance formula. And then now what we're going to do is go ahead and identify our coordinate values. Okay, so we have get this thing going here. Point E is negative 1, 2. So that's our x1, y1, okay? x1, y1. And then point F is 2, 1. That's our x2, y2. So we know what they are. Let's go ahead and go right in. We're going to skip the step of outlining them. Hopefully have it mastered by now. So the distance, D, in this particular example is EF. And that is the square root of x2 minus x1. So x2 is 2 minus x1, negative 1. Square that. Plus, oh, my formula is supposed to be a plus. All right, plus, and then y2 minus y1. No parent in the negatives there, so y2 minus y1. Bam, bam. Okay. Have it all together. Now let's go ahead and use our order of operations to simplify this completely. If we do that, we're going to have, what are we going to have here? We have minus and a minus, so we're going to have to slash and dash there. That becomes a 2 plus 1. Okay. Quantity square plus 1 minus 2 is a negative 1, 180 squared. Simplifying further, we're going to have 2 plus 1, that's 3. Let's make that bigger. So 3 square plus negative 1 square. Negative 1 square is just going to be 1. Okay. Alrighty, so let's simplify this. 3 square is 9. So we have 9 plus 1. 9 plus 1 is 10. So the square root of 10. Now the question is this. Can we simplify our radical 10? Let's see. So radical 10, break it down. We take out 2 and 5. No prime factors repeat. So this is the simplest form. Let's write down our final answer. EF, the distance between the 2 points, is given by the square root of 10. Or you can approximate it making use of your calculator. We're going to approximate it and round it to 2 decimal places. So let's calculate the square root of 10 with our calculators, and you get is approximately 3.16. All right, so there goes the answer to question number 3. All right, let's take a look at some examples on midpoint formula. So number 4, what if you're to find the midpoint of GH, okay, given that G is 12,3 and H is negative 10,3. All right, it's very similar, okay? This is very similar procedure. The only difference is we're going to be using a different formula. So let's go ahead and take a look at that. We're going to start by writing down what the midpoint formula is. All right, so the midpoint formula is given by the average of the x's and the y's, okay? So it's x1 plus x2 over 2. So that's the mean of the x's, and then that for the y's 2, y1 plus y2 over 2. There you have it, okay? So for point G, it's 12,3, and then H is what? Negative 10,3. Let's go ahead and label our points. Let's just call this x1, y1, and x2, y2. They're interchangeable, remember? So it doesn't matter how you name them here, you still get the same answer. Okay, so let's write it out. For G, x1 is 12, y1 is 3. And then for H, x1 is negative 10, and y2 is 3. Actually, x2 is negative 10. All right, let's make sure we have it correctly. X1 is 12, y1 is 3, x2 is negative 10, y2 is 3. All right, so now we're ready to calculate the midpoint. All right, so the midpoint is going to be x1 plus x2, 12 plus negative 10 divided by 2. Okay, that's the midpoint. That's the x coordinate for the midpoint, and then the y coordinate for the midpoint is going to be y1, which is 3 plus 3 over 2. Y coordinate for the midpoint. All right, let's simplify this using order of operations. So we're going to do the numerator here. That's grouped together. So 12 plus negative 10 is the same thing as 12 minus 10, which is positive 2. So we have 2 over 2, comma 3 plus 3 is 6 over 2. And then your final answer, 2 over 2 is 1, and comma 3. All right, so the midpoint of GH is 1, 3. So that's the point that's directly at the middle of these 2 points if you graph them on the same coordinate system. All right, one more problem before we give you some practice problems to try out. Question number 5, the last one. Number 5, let's say you're to find the midpoint of AB, segment AB, given that A is 4, 2 and B is 8, 4. All right, we're going to follow the same procedures that we used for question 4 here. Let's refresh our memory on what the midpoint formula is again. So your midpoint formula is the average of the x's, x1 plus x2, comma the average of the y's, y1 plus y2. Like that. Okay. So in this particular example, point A is 4, 2, and point B is 8, 4. So we know what our coordinates are. These are x1, y1. First one, and then x2, y2. A second one. So we know that x1 is 4, y1 is 2, and then x2 is 8, and then y2 is 4. We're going to plug it into the formula, our midpoint formula right here. So our midpoint is going to be the average of the x's. Let's see, x's are both positive. Nice. So x1, 4 plus 8, x1 plus x2 over 2, comma, y1 plus y2 over 2. Like that. Simplify, combine the numerators. We have 4 plus 8, which is 12 over 2. And then 2 plus 4 is 6 over 2. So our midpoint is 12 over 2 is 6. And 6 over 2 is 3. So let's write down what the answer is. The midpoint of segment AB is 6, 3. That's the point that's right at the center of those 2 points. Okay? So it's now your turn to do some practice problems. Alrighty, now it's your turn to do some practice problems. We have 5 problems for you to try out. So go ahead and pause this video presentation at this time. Try out these 5 practice problems. When you're done, click on the playback button, and we're going to reveal what the correct answers are. Alrighty, welcome back. So here are the correct answers to questions 1 to 5. Go ahead and check your work at this time. We'd like to know how well you did in these practice problems. You can specify it in the comment section below. And if you have any questions about the original tutorial or these practice problems that you like assistance or clarifications on, just put it in the comment section below and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. Please help support this channel with a like, subscribe, and share, and also hit the notification button in order to get updates on future uploads. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.